much. All right, everybody, I wanted to take a couple of minutes and I wanted to talk about getting into Cloud Labs. So I have this tiny URL, free labs free. And right now I'm completely caught up with everybody that has filled that particular form up. So we're ready to rock and roll. But if you go to that URL, you fill it out and it's going to populate a spreadsheet that I have over here, or a database, even though it's just a spreadsheet. And I add you into the Cloud Lab portal. You will receive an email. That says, welcome to Cloud Lab portal. It says no reply at Simplify Cloud Lab. Cloud Lab portal account has been created for you, gives you your username. I removed my password because I can't have you shenanigan-y people jumping in there and, just simply adding in and taking over my account, because that'd be weird. Although now my spreadsheet is frozen. There we go. We got more people coming in. Now you want the labs. All right, so it's populating right now. I'll hit it here after people are working on it. And then you'll receive an email. You'll click that link, log in with your credentials, and you will be confronted with this right here. You'll be confronted with this without the black stack right here. It's going to say Start Anti-Siphon Gold. You click the Start button, and it starts a stack, and it has a number. You can see it says Anti-Siphon Gold 4226. If you want to access it after it's been running, and it should say running, you click over on running copy, and that stack gives you 3 computer systems, only one of which we're going to be using for this course. But the first system that you're going to gain access to is a Windows XP system. That's this guy right here. So cute. And the other one is a Kali system, which we use in my Intro to Penetration Testing class. We use that. And by the way, if we could get a link for my Intro to Pen Testing virtual registration, if any of you want to learn penetration testing and make it a career jump, you should take my class over Wild West Hacking Fest. Yes, that is shameless marketing plugs for my class, but it is truly 2 days completely distilled of like all the things I've learned about running a penetration testing company since 2008, I guess, is whenever I started it. At any rate, so be sure to check that out because we use the Kali VM and we use the anti-siphon VM. Once you're in there, a couple of quick things. It is slow. Like I said, it is slow. It is free right now for running copies. I have, oh God, we've got about 150 running copies at the moment. Let me add a whole bunch of users too, because we just had a whole bunch of users go fill out the form, and I'll get those people added in right now. There we go. Boom. Should be loading them in now. The other thing is you can change the resolution from responsive to full screen. And like I said, this is what I use for my demos because it's just set up and it works and it's slow, which gives me time to talk. But patience is a virtue in this. It is a free cloud VM for a class that Arnie Bellini is paying for on that as well. But yeah, Wild West Hacking Fest, Megan just gave the registration, and that should get you in the registration for being able to register for my class as well. But yeah, there is still virtual, which gets you the whole conference. So that's what we have. Let me throw this URL up here real quick. I'll throw it in the chat so people have it. Thank you very much, Jesse. Appreciate it. There is my free lab free on that as well. I don't need the cloud if you have the VM. You do not. The best possible experience with this class is doing it with the actual VM on your system. For demonstration purposes, I do it in the worst possible scenario, which is the slow cloud labs, just because I'm going to eat my own dog food. I love the fact that Arnie provides this. But I like to do it because it absolutely shows people that it does work and the labs work just fine. So go ahead and get in there and do it, get set up. Oh my God, look at you all coming in. I'm excited. And yes, this is also true for those of you that are on YouTube as well, because I know that some of you are just joining this and you just probably are wondering what in the living hell is going on with this whole entire situation. But this is this is what we do. This is the anti-siphon pay what you can training in anti-siphon. All right, I'm adding in a bunch more users. We're getting there. It's going good. Awesome. All right, but now I need to get to the slides and we need to get working. All right, so we did Linux. We closed out with the Linux command line yesterday. And if you add in your email, it's not automatic. That's by design, actually. So I will add in the additional users here in just a little bit. So don't freak out if you don't get an email right away, and that's fine out there as well. But yes, if you could please give me, somebody could post up a link to Arnie's LinkedIn. And if everybody in the class could go on LinkedIn and say thank you to Arnie Bellini for what he's done. He is absolutely fantastic for offering this up. He's one of those people, honestly. I think Arnie might be uncomfortable me saying this, but I really feel like Arnie is a lot like Andrew Carnegie. Andrew Carnegie he was brilliant. He tried to do a whole bunch of charitable things and built a bunch of schools and libraries around the country. And that kind of became his goal and objective of trying to give as much as he could back to the world. And that's what Arnie is doing. And I really respect him. So please go say thanks to Arnie and what he's doing. All right. So now we're going to be talking about Windows endpoint analysis. And this is going to take us quite a while to get through because we've been building up to this point, right? Like we've been building up to get here. So by the way, do we have a bunch of people here from Jerry just joined? I think we have a bunch of people from Simply Cyber that just showed up, which I think is great. We love the Simply Cyber people. Thank you for joining. We appreciate it. And do a shout out to Jerry as well. He will be keynoting our conference this year. All right. So we've been building up to this point, right? We've been building up to the point where we can start looking at a Windows computer system, which I know is kind of a little bit weird, I guess, right? Like we went through this weird path to get here. We started with network and understanding how networking works. And then we went to Linux instead of Windows. And the reason why we did that progression is because we're going to be creating malware for a Windows computer system and making it call back, to our Linux computer systems. So kind of doesn't make sense to just jump straight in with Windows and get right to it. We need to basically take some steps, understand networking, understand some basic Linux, and then move into the Windows endpoint analysis out there as well. By the way, if you like the GRC Mafia thing, we have some really cool hats in the store. They're Run GRC and the Run DMC style. So check those out. All right, so Windows. When bad things happen, we're going to go through and we're going to cover some core live forensics commands that every SOC analyst should know. Yes, it does take some time for it to start. Sometimes it can take a couple of minutes for it to start completely because Windows takes a while to run in the virtualization that we have in there as well. There's the Spearfish General Store and our shirts, the Run GRC shirts. So check those out. But it's kind of, there's a little bit. All right, so Ranty McRant face coming on here. One of the things that's absolutely just bothering me at the moment is whenever I'm trying to teach Windows command line, whenever I'm running all of these different things, I have people that come to me all of the time and say, yeah, no, we use SentinelOne, we use CrowdStrike, we use Product X. I don't need my analysts to understand Windows command line essentials. And that is really sad. And to be honest with you, whenever I actually pull on that thread with a lot of organizations, not all organizations, but with a number of organizations that have that level of an attitude, more often than not, what they're really worried about is SOC analysts getting skills that allows them to leave and get a better paying job. I know this sounds really jaded and just kind of like icky, but trust me, it's true. There's a bunch of people that have approached me that own companies that are like, dude, if you're teaching people how to do Windows command line stuff and how to hunt with Sysmon and how to hunt with logs and how to hunt with these different things, then they're not locked into the SentinelOne, CrowdStrike, whatever ecosystem it is that they are using at their MSSP or at their organization. And I respectfully refer to those people as assholes. Anybody that's trying to hold anybody down in the community by making it so that they're locked into a technology stack are just not good people. This is nothing new, by the way. This is one of the reasons why Unix is so incredibly powerful. Before we actually had full Unix, which was designed to be portable and free, as in beer and as speech, you would be locked into an IBM ecosystem. you'd be locked into a Cray ecosystem. And those vendors would train you to do just that thing in that vendor space. And if you tried to do anything else, you would have to completely relearn an entire new skill set. Once we got to C, we started getting into GNU compilers, we started getting Unix and things like that. We had a portable operating system that allowed us to learn one language like C, and it allowed our programs to be portable to a wide variety of different platforms. This is also true of Windows. Yes, Windows and Unix wildly different, but they still can use programs that are written in C and C++. So what we're trying to do here is give people the fundamental skills that they need to be able to do their jobs, regardless of the operating system environment they're working in. If you're working on Windows, great, we've got you covered. If you're working on Linux, great, we've got you covered. Anything to do with networking, great, we've got you covered there as well. This is essential for making sure that people are portable and they're not as fungible. That means that they're rare, so that they can get locked into they don't have to get locked into one job. They can move around quite a bit. So we're going to start at the very beginning because it's a very good place to start. We're going to start with network connections. Now, whenever somebody thinks their Windows system is compromised, like if you're at a friend or a family member's house, what is the first thing that you see people do? They think they're compromised, and what is the first thing that they do with a computer when they think it's compromised? What's the first thing they do? Anybody know? They turn it off. Task Manager, right? They do a Control-Alt-Delete and they look at Task Manager, right? Call me, right? What the hell are they looking for whenever they run like Control-Alt-Delete and they start looking at the services? It's like, oh, geez, here's the problem right here. It's evilmalware.exe. Love Vladimir Putin. Yeah, that's your malware right there. That's the stuff. That's the stuff right there. No, God, no, that's not it at all. That's not how any of this works, right? So we've got to start somewhere. We have to start sometime. What better time than now? What better place than here? Because all hell can't stop us now. So what we're going to do is we're going to start at the network connections and we're going to work backwards. The reason why is because there's fewer network connections that you will have to deal with than trying to go through absolutely every single process that you're going to have to cut through. We're also going to show you how you can look at some of these processes and things like dynamic link libraries and how they're actually loaded to get a better understanding of what potential malware is. So the main commands that we're going to look at are going to be netstat, netview, netuse, and netsession. All of them are in fact different commands that give you different perspectives of a Windows computer system, but you're going to start here. So let's start out with netstat. All right, or NetView, apparently. So when we're looking at NetView, all right, NetView does some amazing things. If you do NetView / / 127.0.0.1, it's going to show you the shares that are mounted on this given system, right? So if I were to go over here to my Windows computer, not that one because it's decided to get all poopy on me, and I go to this one instead. So we're going to go ahead, right click. We're going to run this as administrator. It's going to pop up, ask me a question. I'm going to say, yes, please do continue. There we go. It takes a few seconds for it to load. It's going to show me the shares that are available on my computer. Now, why is this important? This is important because whenever an attacker takes over an initial computer system, they like to establish a beachhead computer. They like to establish a beachhead computer system. And with that beachhead computer system, they will many times open a share on that computer system that they can access from other computers that they've compromised, right? So if I go NetView, it's going to show me, are there any shares on this particular computer system? We'll show that here in a second. Now, a really, really cool thing about the netview command is if you run it in an Active Directory environment, it will show me not only the shares on this computer system, but it will show me all of the other shares on all of the other computer systems in that local network. Why is that important? Well, that's important because what we're going to end up doing is we are going to pivot from one system to another, to another, to another. So now if I do net view and I go // 127.0.0.1, there's no entries on this list. So there's no publicly available shares on my computer system. Now, before you ever get into an incident, what would be one of the most important things you would do about this command before you get into an incident? What would you want to check on first, right? What do we want to check? Get the baseline. Get the baseline, right? You would want to know what is normal. If your systems normally have some type of weird share like admin or help desk or whatever, that's a bit weird, but you would want to make sure that you would know what normal is before you get into an actual incident moving forward on that as well. So that's the first command. So let's go ahead and let's move on to net session. All right. Horrible analogy, but I want you to think of a computer centipede, right? So you have computer X gets compromised. I pivot to computer Y, and then I pivot through that computer to get to computer Z. All right. You may look at this incident and initially do this analysis on machine Z. All right. Or Z, as they say in Europe. I may start at machine Z and I have to work backwards. That doesn't mean that like any alerts were generated for X and Y. You got an alert for Z. So if we're doing this analysis, we have to find a way to say who has sessions open with my existing computer, active sessions, not a share. They're logged into my local computer. And who is my computer logged in to? If I run net session says who is currently talking with the current computer system. And going back to my computer here, if I do net session, I have no entries on this list because I haven't hacked it yet, right? So we haven't compromised this particular computer system. But if I had a computer that had compromised, let's say system X, and then it pivoted to system Z, now I know I've got to follow that thread and now do an investigation on machine Y. And with machine Y, I can see who has open sessions. I can see it as a session open from X. And now I have to do an investigation on machine X. So it's not an issue of looking at it. No, big endian is not backwards. Little endian is backwards. So if you're looking at Intel CPU chipsets, all the data that's rolled into memory is put in little endian, which is backwards. It's mirror of what you and I see with memory address locations and values. Big endian is the way that you and I would look at them as well. So there you go. All right, so let's keep moving. Net use. Who is my computer talking to? So now let's say that my computer is compromised and it's machine Y, but machine Y is communicating and compromising machine Z. So what I can do is I can create a session, and then I can do that like this. So I can do net use star, and then I do whack whack, and let's just do 127.0.0.1. It's going to pass my existing credentials. C dollar. All right. So now I've mounted a share. I only have one computer, but I've mounted a share from my computer over to another computer system, which is my computer. But if I do net use now, like that, now it says I have a share open on this other computer system and the drive letter is Z. This is another way that an attacker would actually mount that session from my computer over to another computer. And once again, this is one of the most horrific things about incident response and what's happening in the industry today. Incident response and computer forensics is an absolute disaster. And there's a number of reasons for that. But one of the main reasons is, I mean, I could blame some people. I'm not going to blame people. No, I'm not going to pick people to blame. Nah, we're not going to do that. No, not. But one of the main reasons for that is the industry as a whole never really gelled in the IR space about what quality work looks like and what incident response reports look like. And they got focused on the tech. So there was no like measuring stick that could say, these are the steps that someone should do from an IR perspective. Is Zach on this? I don't know if Zach's here. Can I? Yeah, I need to get a note to Zach. Hold on. Let me send something. Let me do this. Let me send this over. Zach. There we go. So I need to create. I'm also going to send it to Patterson. There we go. There we go. Off. All right. So the point of what I got sidetracked on was we don't have anything in the IR space that says this is what due diligence is. Like if somebody's going to work IR, these are the commands that they will go through. These are the things that they will view. These are the things that are going to be in their goddamn report. Instead, what we have is we have an IR race to the bottom, and this is all to blame to the insurance industry. There's other people, but I'm not going to name names, but they kind of allowed it to happen. But the insurance industry basically says we will pay for incident response services for companies, but we'll only do it with authorized IR firms. And the insurance company do not give a shit if that firm is a good firm that does quality documented work. They don't care. The only thing they care about is what, folks? Incident response. What do they care about? Only thing they care about. Money, Mr. Crab. Money. It's all about the money, right? So they go with who is the cheapest. So they created this myth in the IR space that the reports are crappy reports because they don't want to give too much information to opposition attorneys, which is a lie. So a lot of the IR reports that you look at are just like straight up hot garbage. It's like, here's what we found. There's no investigation of like the stuff that we're talking about here. Was the system that was compromised, did it pivot to another computer system? And we see those commands. Is there documented proof that you checked this? And right now, there isn't anything like that. So that's what I sent off an email to Zach and to Patterson Cake is say that we need to come up with an IR reporting standard that says these are the things that you need to be documenting in IR. And these are the methodology steps that need to be documented. And this is the supporting evidence that needs to be provided as part of incident response on this stuff as well. Yeah, this is why you hire BHIS. Yeah, we have people that, oh, by the way, you know what the average cost is for IR through insurance? Like if you go through your insurance company, you hire one of their trusted IR firms, what their hourly rate is usually. It's about $115 an hour. And this gets into something that is bothering me. Can I get some shout outs from my peeps that are here from India? Do we have anybody on this in this class from India? Where are all my Indians at? All right. So what's happening is they go and they hire a bunch of people out of India. They pay them as little as they possibly freaking can. And they basically use them for that work. So India, Pakistan, all of that area, they hire these people, they pay them absolute dog shit garbage. They take that profit even at $110 an hour, and the whole entire time they take advantage of an entire group of people that have amazing computer security skills, but they're paying them peanuts. So yeah, a little mad about that, a little salty about that. So I just want to call out our folks in India. We see you, and we're going to try to get this better. And pretty standard, really, right? But I think it's absolute garbage the way it doesn't have to be. It doesn't have to be on that as well. All right. So what we need to do is need to start documenting what is required for people to do the right thing to get the information that they need out of it. NetStat. And by the way, outsourcing, yeah, absolutely. But you should take it, you should really take care of your people, regardless of the country that they live in. We can talk more about that as well. All right. So NetStat shows me network connections. And as I said, NetStat gets complicated really quickly. If I just run NetStat by itself, this is like the command line equivalent of doing Control-Alt-Delete. It's like, oh, yeah, we're not getting a lot of information out of this. We got the foreign IP addresses, we've got the state, like whether or not it's a valid state. But if you were looking at this command right here, if you were looking at this command, what would be some things like if we were looking at the netstat command, it gives us the local address, the foreign address, and the state. What would be some things that you would want to have added to make this command even more awesome? Like if you're like, this kind of sucks, but it could, be better, what would you do to make this command better? What would you guys want to see there? Some filtering. I like that. That's a good idea. What would be some other things that would be fun to have? Filtering, virus total lookup. We ain't getting that. I'm sorry. Processes. We will get to it with deep blue CLI and deep white CLI. Process ID. We do have the port. We have the foreign address. You can see it's HTTPS. Yeah, yeah. So what we can do is we can take this command and now we can kick it up a couple of notches. So we can do netstat minus NAOB. Now watch this. This gets really cool. So when we get netstat NAOB, I am now getting some things that are really super cool. All right. So the first thing that I'm getting is I'm getting the process ID behind this network connection. So hot right now, right? And I'm also getting what is the name of that process and that executable, right? So we can see SVC host, event log associated with SVC host, local security authority subsystem service. But then we have a bunch of them that say we cannot obtain ownership information. What do those mean? What do those mean? Anyone know? Needs admin? No, that is not it. I am admin. You look up here, it says administrator. It's dodgy? No, it looks dodgy, right? It does, but it's not. Service account, Andrew's getting close, getting close. Lucy's like, it's infected. No, it's not infected. Wildcard, I'm giving you, Andrew is so far the closest. Cyber Gumby, not behind a firewall. Xidis, got it. Round of applause for Xidis. Zidis, I'll go with Zidis. Nailed it. It's the system process. Look at the process ID right here. That's the system process. Anything that started with the system process gets a process ID of 4 because it's one of the first processes that start. And anytime you look at it, it says cannot obtain ownership information. Does that make sense to everybody? Now, is this something I would expect absolutely everyone in the universe to just know intuitively as soon as they sit down at a computer system? Hell to the no, absolutely not. That is not, no, that's not what I expect here. But these are the types of things that you need to learn if you're in a class and you're learning like core Windows Live forensics. Because if you ever end up in court testifying on the stand, you're going to get asked questions like that. Like they're going to say, hey, we noticed that this says cannot obtain ownership information. And you're an expert. Could you please explain to the courts what that is? Now, I've been doing this. I'm like, excellent question. What that actually is the system process. And all Windows computer systems everywhere in the world, if you look at the netstat NAOB, the system process with a process ID of 4 will always say cannot obtain ownership information. That's just the way it is in every Windows computer system. As you said, genetic memory is just something that you did that as well. So if we're going back to the slides, we have the netstat command, but we make it better with NAOB. All right. NAOB. A means display all active TCP and UDP connections. N, display the active TCP connections and port numbers are displayed instead of trying to resolve it to the service. O is the process ID and B is the executable associated with it as well. So Exodus. Okay, that's Exodus. It's it's like I'm mispronouncing things in an uncomfortable way as an English as second language thing, right? But there you go. Thanks for the clarification. So this is what netstat NAOB looks like. And as you can tell, it is just awesome. How many times have I testified in court? I've testified in front of a judge and jury once, specifically in the Capital One case. That is the one that's public, and you can see that one. I was part of that situation. And then I've also testified as an expert witness in depositions a number of times, like a lot. Very similar experiences. Court tends to be a little bit more dicey. And maybe I'll tell you more about the Capital One case as we go through. But the other case that I have been publicly like outed on was the Colonial Pipeline case. With the Colonial Pipeline case, they basically quickly went to the press and they said that they were using me and Rob Lee from oh my God, what's the name of that company? Dragus. So those are the two that I was exposed, and it's publicly available, and you can look at those things. So there's other ones that I did depositions. The other one that I did a deposition that was a public case was this one, United States. United States versus Cobell. This is right here, Cobell versus Salazar. This is the other case. If you do some digging, you'll find some information associated with me on it as well. But like I said, I've done depositions in a number of other cases, but those are the three ones that you can actually research and my name is associated with it. So there you go. Don't say that word. Oh, Sands. Yeah, we're going to stay away from that. All right. Netstat minus F should be cooler, but it's not. Netstat minus F is where it's supposed to do resolution on the IP addresses. So if I do netstat minus F, like so, it takes a while sometimes, but if it can, it resolves it. But if it can't, it just gives the number. And many times it just can't, which I think is just poop. It should be better at doing resolution of DNS names, but it just doesn't. But it's a start, right? I mean, it's something. It's not horrible, but yeah, it's something, I guess. So, all right. So now we've looked at the network connections. Now, the network connections that I would be focused on would be the ones that are established. I wouldn't be so interested in the ones that are star or listening. But I'm really, really interested in the ones that are established connections because those are connections that are generally outbound connections to third parties. So I would focus on these established connections that aren't 127.0.0.1. And I would look at them and say, okay, well, that's Google, that's Microsoft, that's Google, this is Google. But I would start doing research on those IP addresses. And the reason why is we're trying to take this needle in a haystack and break it down so it's a lot more manageable for us and what we're doing. So we'd start there and then we'd look at those processes in more detail. So going back to the task list command, we did netstat by itself, which just sucks, right? So if we do netstat like that, it sucks. If we do netstat minus NAOB, it rocks. Okay, that's awesome. And so if we do task list, the same game, right? Task list. So if I do task list like that, did not do that correctly. There we go. Task list by itself just sucks, like so incredibly hard, you guys. It's just not useful. If we're looking at this particular slide or we're looking at the screen, what would be a really good name for your malware? To kind of kick it up a few notches and blend in and hide a little bit better. You're going to name your malware something. What are you going to name that malware? Yeah, SVC host. You're going to name it SVC host. And that's a great name. And by the way, a lot of anti-malware defenses, they specifically look at anything that has a name of SVC host for the explicit purpose of trying to blend in. But a lot of AV will actually detect that, hey, there's some weird SVC host shenanigans going on. So that's really cool, right? But still, that name, I mean, this does nothing for me, right? This monkey has only one S. It's no use. All right. So what we want to do now is we want to kick that task list command up so it's a little bit better. So we're going to go SVC like that, and bam. Now I know what each of those SV hosts actually is because it started by services controller host. Services controller host is the process that starts services, many services, on a Windows computer system. And when you look at this SVC host, it's now telling you what is the service that it started. So you can see that this one started WinRM. You can see that this one started USO services. What are some other ones that we've got there? Tablet input service, didn't need that, but it's running. But we have all of these services that are spawned out of SVC host. So that really, really kind of helps narrow down exactly what is going on with it. Now, some other people brought up some DLLs, some dynamic link libraries. So yesterday, I talked a little bit about dynamic link libraries and how they're really like real libraries of straight up, real, honest to God functionality. Like, think about your computer with all the DLLs or the SO files on a Linux computer system and think of them as books of functionality. And you go to different chapters, and there's different chapters that have different little code snippets that basically tell you or tell your computer how to do a specific type of functioning. So now what we want to do is say, for these executables, how do I know which library books or DLLs are loaded into that executable? This becomes really critical here in just a little bit. So just give me a second. Let's do this task list. And then let's place the SVC with M and check this out. Now I'm seeing every single executable, but I'm also getting a list of all the dynamic link libraries that executable is using. Now, this can seem a little bit overwhelming, and trust me, it absolutely seems that way. But let's say we wanted to play around with some malware to get a better understanding of what is the dynamic link libraries that would normally be loaded into a piece of malware, like a meaningful bit of investigation and learning. So I'm going to open up another command prompt and we're going to start up some malware. So I'm going to go into tools and I'm going to go netcat, listen on port 2222. And we're going to execute cmd.exe like so. All right. So, oops, minus E, got a little bit ahead of my terminal. There we go. So now I've created a piece of malware that is listening on port 2222 and it executes a command shell when someone connects to it. What are the dynamic link libraries that we would see loaded in a very basic piece of malware on my computer system? So let's go through my own analysis, right? We're going to start with task list, or sorry, netstat. So we're going to do netstat minus NAOB like so. And we're going to look for my netcat listener and we're going to see it's listening on port 2222. See if I can blow by it. Okay, there it is, right here at the top. All right, see it? So now I have this process ID of interest. So I'm going to take this here process ID and I'm going to copy it. And let's do an investigation on that process ID, right? And then if I do taskless space /M, this is all of them, but I have that one process ID that's interesting to me. So what we're going to do is we're going to create a filter. Did I screw that command up? Hold on a second. Let me check something here. I have to go quickly to my own stuff. I know I just screwed that up because I just did it on the fly. Here we go. It's down at the bottom. I always get the FI for the filter messed up right there. Oh, I got to do /FI. That's what I did wrong. All right. So we're going to go /FI like that. There we go. So now we have the dynamic link libraries associated with this really, really basic piece of malware, right? So we've got taskless space /M /FI PIDEQ, and then I put in the process ID. Look at those DLLs. All right. Look at those DLLs, right? So this DLL list is the core basic DLLs that are required for malware to execute properly on your computer system. Either shoveling a shell, opening up and listening on this as well. We have, no, I just screwed up on my command. I forgot the / in the FI, but yes, I screw up too all the time. You guys have no idea how much I screw up. Have you guys noticed how many times I've hit Control-L on my Windows terminal to clear it? You see this? That's how you clear your terminal on a Linux system. So every time you see me doing that, like Control-L, I'm trying to clear my terminal, and that's not it. On a Windows system, it's CLS that clears your terminal. So I F up all the time. So there we go. So we've got our dynamic link libraries, all right? We have our dynamic link libraries. Another question was, is it possible to get this training more than one time live? Absolutely. It's free, or pay what you can. And also it's recorded. If you go to the resources, yesterday's videos are there and today's video is going to be there as well. You can just basically see it as much as you want, recording or join it as well. All right, so these are the core dynamic link libraries that you need to run your basic malware, right? You see NTDLL, Windows on Windows 64, Windows on Windows 64, Windows, and then CPU. So it's not World of Warcraft. Some people get that a little screwed up, but it's WoW, which is Windows on Windows. All right, so let's keep going. We already did taskless space / SVC for seeing the services as well. So we've got that ready to rock and roll. And we did taskless space / M, where I just basically off-wrote it and did it on my own. And then NT, oh crap, I forgot about that one. The other thing that you can do with taskless, check this out. So you can do task list / M, and then you can give it a dynamic link library of interest like that. And now it's going to pull every process that is using that specific dynamic link library, right? And Sam got it. Netcat listed on port 2222. Oh, nope, the cmd.exe. Right, that tick, you got to do tick E for execute space cmd.exe. Sam. So really, really close, really close. That was the first time I typed it and I screwed it up. But you need that E in there as well. All right. This is the one that I just messed up a little while ago, taskless space / M, where we're going to list all the dynamic link libraries. Jelly Beanster's got it right. And then FI for the filter. And I forgot the /. And then PID equal the proc ID on that as well. Yeah, Netcat running as a red flag, but remember, I could rename it to something else, right? Like I could rename Netcat to SVC host or services or whatever I wanted to name it, right? There's some names that I would avoid, but whatever. You can come up with a name that's going to blend in as well. All right, next one is WMIC process list full. WMI is Windows Management Instrumentation, and C is the command. This allows us to see all the process information. We can get process hierarchy. WMIC process get name, parent process ID, and the process ID as well. So we can see what process begat what process. So you can see in the beginning, the system idle process begat the system process, and it was good. And then the system process begat the secure system process, the registry process, and the systems management subsystem service, and it was good. It's like we can see that hierarchy of what begat what other process. And we're going to be doing that here, and we're going to be doing it for memory analysis as well. Finally, we can get command line invocations. So we can do WMIC process where the process ID equals the process ID that is interesting, get command line, and bam, it's going to give us the command line invocation of that process. So hot, so cool. Now, there are tools that make all of this a lot easier in the world of PowerShell, and I think that that's great. But Deep Blue CLI is one of those tools that's great. We're going to be playing with this a little bit later. So we're going to do the Windows Command Line Lab. This is going to take us up to and through the break and a little bit of time after the break. This lab is a pretty big one. Why is this lab a big one? Because we're creating malware. You get some malware today. Even better, you get to create the malware today. I'd call to say, bomb, 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 we created malware today. Doesn't really mean that much to me. All right, so here we got Windows command line. This is the lab that we're going to be doing. Let me put that in. There we got it. You're all hackers now. You're all hackers. So we're going to open up a command prompt and we're going to disable our antivirus. I know that this is a little bit disappointing for some of you as well. You might be running into a problem, like just kind of understanding what we're doing. The goal of this lab isn't, hey, let's create malware that bypasses antivirus. No, 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 no. The goal of this lab is to create malware and then detect that malware as well. That's what you need to do. If your Cloud Lab instance is stuck, sometimes it just gets hung up. Try clicking over to the Kali VM. Here, let me show you how to do that. You would go to responsive. You would click over to Kali and see if it loads. And this is the equivalent of turning it off and on again. So there I've gone over to Kali. Now I go back over to anti-siphon and I connect into it. And that's kind of reestablishing the VNC session. That's one way to do it. And the other way to do it is just start a new stack. Only do that once or twice and then get a hold of me. And we might need to blow away your account and recreate it as well. But right now for running copies, how many running copies do we have? Right now we have this many running copies. So a lot of people are in and doing their jams, which is great. Very excited about that. I have a couple more people I'm going to get added here in just two shakes of a lamb's tail. But no, we're going to go ahead and we're going to do this lab. You're going to disable antivirus. Once again, the goal is to learn how to detect malware, not bypass AV. If you want that, go check out Joff Thayer's class. That's a class that'll teach you how to bypass antivirus. And then also Michael Allen's class as well, which is really, really cool. The labs are all in GitHub, Ravi. Let me post this up there. There you go. You got it. And then we're going to do ifconfig on our Linux system. So we're going to open up a Linux terminal. How we go about doing that is thusly. We click the drop down and we do Ubuntu 1804. Only use Ubuntu 1804. That's going to open up Windows subsystem for Linux 2, and we do ifconfig like so. We get our IP address. Awesome. Very good. Then we're going to run this really long command, really crazy long command. I want to see if my Zoom works. Is my Zoom working? Can you guys see this? Is it zooming? Is my Zoom zooming? Zoom. All right, it is. It's awesome. Sam, you got red. Read the next paragraph. Read the next paragraph, Sam. What does the next paragraph say? In the instructions, what does it say, Sam? All right. So with the zooming, you should see like your Linux IP right here. You have to replace the greater than and the less than with your Linux IP address. It is a variable. So you're going to put that in. All right. So let me show you what that looks like. So I'm going to copy this command right here. And I'm going to do this really quick. So I'm going to do sudo we're going to become root like so. ADHD is the cool password. ifconfig. There's my IP address. Now I'm going to type clipboard text in. It's going to type in the command to create the malware. And I am going to go through and I'm going to replace my Linux IP address with my Linux IP address. So I'm going to do this like so. Mine is 172.170.153.230. So I've just created my malware, right? And I won't hit enter because I want to do the walkthrough, but I replace that variable with my actual Linux IP address. Then you're going to cd into the temp directory. You're going to see that you have trustme.exe. You're going to copy trustme.exe to your Windows computer system. We're literally point blank copying the malware to your computer, which you may think is kind of lame, but you're wrong. And I'm going to explain why you're wrong if you think it's lame, because it's awesome. And I have do you guys want some juicy pen testing snackies that a lot of people don't know from an offensive perspective when we come back from the break? Yeah, you do. Yeah, you do. There we go. Yeah, we'll talk about that when we come back. I'm going to run MSF console. We're going to use exploit multi-handler. We're going to set the payload to be Windows Meterpreter, reverse TCP. We're going to set your host to be your Linux IP address. Then we're going to type exploit on that. All right. Then in another window, we're going to go to C tools. We're going to run the malware. Now we're going to have that malware execute. And then what we're going to do is go hunting. We're going to create shares. We're going to look at our shares. We're going to mount sessions. We're going to look at our sessions. We're going to run netstat minus NAOB. We're going to go through and do netstat minus F, which is going to be a huge disappointment to everybody. Then we're going to run netstat NAOB again. We're going to zoom in on that process ID. And then we're going to get the command line invocation. And that's this lab. So this lab is going to take us almost an hour. I'm going to give you a lot of time to work through this lab. If you have questions, go into tech support on that as well. And I will do the walkthrough at 10:45. 10:45. So whoever's setting the break timer, you've got to set that timer for almost, let's do it for, I think, what is it, 50 minutes or something? No. Yeah, it'd be like 55 minutes. So lots and lots of time. This is going to have the break. You're going to walk through this. You're going to do it, and then you're going to do it again. If you have time, you should do it multiple times just to get used to it. But we're going to take this for almost a whole hour, 1:45 Eastern time. Get to it, everybody. I have a couple of people I need to add to the Cloud Labs. Here we go. Copy. paste it in. There we go. We're adding in those users. So with that, folks, let's get to it. And then I'll be back. And then we're going to spend 15 minutes where I'm going to walk through it slowly with everybody. And then we're going to take another break. Like this literally is taking a huge chunk of the class today. Half of the class is with this lab because it is just that important. So get rolling. If you need anything, please let me know. There we go. Now I'm unmuted and now we are ready to get started with this lab. All right. So I kind of walked up to this line in the lab because this is the biggest mistake that people make in the lab. And I left it on my screen where they're running the MSF Venom command at this point in the instructions right here. Right here. And this command, this right here is where people make the most mistakes. Right here. It says your Linux IP. And you have to put it in just like it would be without the brackets. And I had that up on the instance right here. So I'm copying and pasting. I have my IP addresses here. The other mistake, well, that's the mistake, is people don't put in their IP address. So I replaced that bracket, your IP address bracket, with my IP address. So I've got that set up there. And now everyone's talking about sandwiches, really going. All right. So now I'm going to hit enter, and it's going to take a little while for it to run. What it's actually doing, this is, believe it or not, Metasploit is the largest Ruby environment in the world, the largest Ruby project in the world, and it's loading up a bunch of libraries to actually create our malware. So let's go through this command step by step while we're waiting. MSF Venom is a command that is actually a wrapper for two separate commands, MSF encode and MSF payload, at least it was. And MSF encode and MSF payload were two separate tools at one time. MSF payload was a tool that allowed you to export all the different payloads of the Metasploit framework into a variety of different file formats. MSF encode, its initial purpose in life was to encode the binary to avoid bad characters. Bad characters like terminator strings. If you're looking at string copy functions and things like C, 00 is a terminator string. So it would be FF and AF. So encode would allow you to encode your payload to avoid bad characters. But the cool thing is that little trick on avoiding bad characters and encoding actually allows you to bypass a lot of standard antivirus engines. So people started using it. And the first person I'm aware of that did this was Mark Baggett, the first presentation I ever saw on this. Mark was using MSF encode in a way that allowed you to encode your binary to bypass AV engines on there as well. They should have the quota uploaded. I sent them a screenshot. I haven't gotten anything from Robert. Let me check Robert on that. Any luck? We'll see where they're at. And tell my students are still getting the quota issue, specifically in the Tampa region. Like I said, these guys are doing this stuff for free. We appreciate it. They're all working hard. And right now there's 350 people that are running VMs. So there we go. So that's what MSF Venom does. We're saying the architecture is x86, which is a 32-bit payload. The platform is Windows. Now, that actually means quite a bit because whenever it creates the malware, it's going to be written specifically for the PE architecture of a Windows operating system in there as well. What's really, really super cool about that is it actually embeds the malware inside of an executable that was called ab.exe, which is Apache Bench, is the default template. Portable executable. And then the payload is Windows Meterpreter Reverse TCP. We're setting the listening host is the IP address up here. That is the variable that we change, 172.17.153.230. The L port is 4444. The output file format is an executable. And then the full file name is temptrustme.exe. Awesome. So it looks like it should. So I'm going to go into the temp directory. So we go into temp, type ls, and there is our executable trustme.exe. Now, the next step of the lab is we have to copy that trustme.exe executable over to our Windows system. So I'm going to type in the clipboard text. There we go. It said should be updated momentarily. They're keeping me updated. So now we moved it over to the Windows system. So I'm root already. So I'm going to do MSF console. The instructions say start a new terminal. We can do that. I can just create a new terminal. And I'm going to do Ubuntu 1804, not 1804.05. So we're going to become root like that. And then we're going to type in the clipboard text and we're going to start MSF console. This is creating the C2 infrastructure. We've created the malware, and MSF console allows us to create the infrastructure to receive that reverse connection coming off of the malware of interest in our computer system. So that's what we're setting up here. So we've got it running. Now we're going to set our payload, or sorry, our exploit is going to be the multi-handler. This one is interesting. The multi-handler is, if you're looking at how Metasploit is structured, it breaks things up into exploits, payloads, auxiliary modules, things of that nature. So when we use an exploit, usually the exploits are categorized and broke down in operating systems. So there will be exploit Windows, exploit Linux, exploit OS X, exploit Solaris. You have different operating systems. When we choose multi, it's multiple operating systems, and we're using an exploit of a handler. This is just going to allow us to run a payload and wait for it to receive the reverse connections, regardless of the operating system. So we have that set up. Now we're going to switch over and set the payload to be Windows Meterpreter Reverse TCP. One of the other problems that people run into in this lab is they try to type everything and they misspell Meterpreter. They misspell it to be like meter Peter, I guess. So we're going to use copy and paste because I don't like those errors. So we set the payload with Windows Meterpreter Reverse TCP. There we go. And I want to show you something. If you mistype it, like if I go this TCS instead of TCP, it says a payload is not valid. So we need to make sure we're not getting those errors and just rolling on through them. That if it gives us an error, we take a second and we find out where a typo is. I'm going to set the L host to be my Linux IP address. We put that in, and I've got my IP address way up here or over here. There we go. So I've got my Linux IP address here. Old school, I like to make sure my stuff is very specific instead of a variable. There we go. So now we've got the L host is set. And then I'm going to type exploit. And this is another area that people kind of ran into some shenanigans. They type exploit and nothing happens. No session is created. That's because we haven't ran our malware yet at this point. So we need to go through and we need to execute our malware on our Windows computer system. So I'm going to do that now. I'm going to cd into the tools directory, and I'm going to run trustme.exe. There we go. Now I should go back, and over here, I've got a Meterpreter session, and this is one of the final mistakes that people made. They just see a Meterpreter session, and they're like, it didn't work. It didn't work. It did. You got a Meterpreter session. You have now hacked that system. I can see processes. I can see what are the different files. I can do all kinds of stuff. I can run a keystroke logger. There's a lot of stuff that I can do from a Meterpreter session. But at this point, I now want to start hunting the malware. Once again, it's not that we're trying to here's how you exploit a Windows computer. We're not doing that. We're saying, how do we detect malware on a Windows computer system? But give me two shakes of a lamb's tail, and we'll talk about exploitation of Windows computer systems here in just a second. So I'm going to open up a new command prompt. I am running it as administrator, which is absolutely essential for this to work properly because we're hunting malware. So we have our malwares executed. We can create a share from the command prompt, or we can create it from Meterpreter too. I can do shell, and then I can type in my clipboard text like this. There we go. And then to hunt that share on the other side, I can do netview 127.0.0.1. Let's see if there's a share that shows up. Type clipboard text. Sure enough, there's our share. There's now a class share. Once again, you'd have to know if that was normal or not. We can also go back to the Metasploit session and do net use star. You can do it from either one. It doesn't really matter, but I'll run it from the Meterpreter session. We'll paste that in. There we go. And then I can do net use like so. There we go. And we've got our shares mounted with ourselves. So that's pretty cool. The next thing is let's start hunting our network connections with netstat naub. I'm going to paste that in and we're going to look for our Meterpreter sessions IP address. I'm also going to bring this down. Let's go to full screen. Going full screen. There we go. And let's look for our malware. Oh, there it was right there. There it is, established. So we know that it's trustme.exe and we have this process ID right here. That is the process ID of interest. We're going to hunt that down. I'm going to paste that in there. That's good. And then we're going to run some commands on that process ID. So let's go ahead and there we go. So we're going to run this one first. Type the clipboard text. And I'm going to put in the process ID, which is 7636. There we go. And do those dynamic link libraries look familiar, everybody? Do they look familiar at all? They're the same dynamic link libraries as our netcat command. Now, does that mean it's always evil? No. Different malware specimens will inject in a variety of different and creative and wondrous ways. We just have to be careful about that. But this is what we call a pretty good indicator. A lot of work that you're going to be doing in a SOC is looking at all of the alerts, and you're going to be making a determination insofar as like which alerts are the richer alerts and that should be investigated with more vigor. If you have a potential executable that's got these 4 dynamic link libraries, it is absolutely going to be something you're going to investigate with much vigor in your security operations center. All right. We can see our process heritage right here. Oops, shouldn't do that. Type clipboard text. There we go. And we can see our cmd.exe was begat by this process up here, which is trustme.exe. So check it out. So we have trustme.exe is 7636, and it was invoked by 6908, which is another executable. But then you can see that that spawned off cmd.exe as well. So we can see that hierarchy of what process started which other processes on the system. And let's get the command line invocation, huh? Let's do that. Copy that. We're going to paste that in there. We're going to set that process ID to be trustme.exe's process ID, which is 7636, 7636, like so. And we can see that it was just ran command line trustme.exe, which is kind of boring, but it's still pretty darn cool that we could actually see that executable was running in there as well. So that is the lab. This is absolutely a lab that I recommend you do multiple times. If you struggled with it a little bit, absolutely, wait till things die down in Cloud Labs and come back. I'm still waiting for Robert to up our quota. Once again, good problems to have. I know it's frustrating, but it's free, right? These are a group of people that are doing this out of the kindness of their own hearts. They have other job things that they're doing, and they're helping us out. And I really, really, really appreciate it. And I know it's frustrating. I understand that. But just bear with us and bear with them. It's what we do, right? We got lots of people that are trying to help and they're trying to increase the quota size. Also, to be completely honest with you, there's not a lot of training classes that run with 400 people logging in at the same time. How can you detect on DLLs or modules? Well, one of the things is what are the DLLs or modules that are loaded, JSON Sylvia. If we go back to the other command that I just ran a little while ago, if I go here, looking at these dynamic link libraries, that could be an indication that there's something wrong with those as well. So it's all about investigation, right? It's all about investigation. on that. All right, so we're going to take a quick 10-minute break. And when we return, since we spent all morning, we're going to jump into another lab that's going to go through this stuff a little bit faster with PowerShell. And it's going to be looking at event logs because there's more than one tool. We told you how to do it by hand, but what if we could do event log analysis to detect it? So let's set the clock for 10 minutes. We will resume at 12 after. Sorry, I'm late. I'm late for a very important date. I went to go make myself a cup of coffee real quick. Mmm, that's excellent. All right, so let's go ahead and let's talk a little bit about tools that you have at your disposal to be able to do this stuff a little bit easier from an investigations perspective. Now, some people were asking, what is the coffee I'm having? Does anybody know what is my favorite coffee? Like if you're watching my webcasts and trainings, like usually what is the coffee I am drinking? Mm, yep, usually decaf. Um, specific instant decaf. Yeah. So pure cocaine. We have a coffee shop now. Um, it's the Brewberry Bistro. You can look it up in Sturgis, South Dakota. But we have a full coffee shop. So I've been making lattes. Specifically, I made a golden latte with some turmeric and stuff today. So I am kind of moving away from the instant decaf game out there as well. We do not, but our coffee is roasted locally. All right, so let's get rolling. So Deep Blue CLI allows you to look at the event logs on a Windows computer system to be able to identify indications of compromise in a little bit more detail than what we would do just by hand and trying to do analysis of it. As there's a lot of evidence points. And this gets into one of the things as a SOC analyst that every SOC analyst has to be good at. It's not an issue of being able to use one tool. It's an issue of being able to use multiple different points of information to correlate and fuse to come to a conclusion. Doing live forensics is absolutely essential to what we need to do to be able to detect an attack and possible malware on a computer system. But that's one point. Another point is looking at the event logs on a Windows computer system. Which event logs? Excellent question. It turns out that there's weird event log settings that we cover in the next class that allow you to enable command line logging on a Windows computer system. And that's what this tool requires. It requires command line logging so you can see PowerShell execution. It's actually PowerShell logging and command line logging so you can see what is executed on the system. Is very good stuff. Is very, very good stuff. And this is what it can detect, right? User creation, added to groups, password guessing, password spraying, bloodhound type access, long command lines, regular expression searches, obfuscated commands. It slices, it dices. It's awesome. You should check it out. It's so cool. But wait, there's more. We can go deeper. So if we look at an event log and it says, hey, there's something suspicious, we can run some PowerShell to do some quick analysis to find shenanigans. Shenanigans! So you can see we have get when event, filter hash table. We give it the path to an event log. And then we say ID equals 4672 with privileges as assigned. And we're doing a search within that event log for the name Bertha Schultz. Why? Because back here, you can see that there's multiple authentication attempts from Bertha Schultz, right? That's kind of neat. But wait, there's more. It also has something called Deep White CLI. Now, let me show you this. So if I go back to my VM and we do some VM type things, right? So if I go into Event Viewer, go to Event Viewer, we run Event Viewer, wait for it, wait for it. There we go. You go to application and service logs. Just give it a moment. There's a lot of logs. So many logs, you guys. So many logs. There we go. We go to Microsoft, Windows, and then Sysmon operational. It also has the ability to look at Sysmon logs. Now, Sysmon is usually not enabled on Windows computer systems by default. It is enabled on this particular computer system. And you can see just how much more powerful the event logs are when we have sysmon enabled. So here we can see that we have event logs that are created, event ID 1, that gives us the name of the executable that was being invoked as well. So it gives us a lot more detail about those specific event logs and than what you would normally get. So here, let me pull this up. Window's so small. So there we go. So now we're getting a lot more data about these event IDs. Specifically, we can get event ID information like what is the name? We can get what is the process ID, the image executable that was ran, the product, the company, the original file name, the command line invocation, the directory it executed from, the user it executed from. It gets the MD5 hash. It's not just the MD5 hash. There's imp hash, and they have all these hashes. Parent process IDs. Oh my God, this is so cool. This is so cool. And Sysmon has the ability to parse these logs as well to give you information about a potential attack on those computers as well, which brings us to yet another lab, which is going to take us 15 minutes. And I will walk through it again. But in this lab, you're going to be using Deep Blue CLI. And the name of the lab is coincidentally Deep Blue CLI. So in Deep Blue CLI, the same thing that we did in the last lab, where we're going to fire it up. And if you don't get your command prompt opening right away, that's okay. We give you alternative instructions, multiple ways to open an Ubuntu prompt, PowerShell prompt, a Windows command prompt, all of those as well. And you're going to set the execution policy unrestricted in PowerShell. You're going to run Deep Blue CLI against event logs with weird attack traffic patterns on them. And when we come back, we're going to talk about these attack patterns in more detail. So with that, let's get rolling. Let's set the timer for 15 minutes for this lab. And when we come back, we'll do a walkthrough. So we are going to continue with said lab. Now, this particular tool is just a stand-in for a number of different tools. I'm a little bit biased because it's by a good friend of mine. Eric Conrad and Seth Meisner and like that crew, we go way back. They are SANS instructors, and all the SANS instructors are my brothers and sisters. I may disagree with some of the business decisions that SANS does, but honestly, their instructors are really solid, top-notch instructors. Once again, SANS, Cyber Mentor, and of course, this little startup company called Anti-Siphon, which I think is pretty good too, honestly. But anyway, so let's go through this lab and let's do it. All right. So the first thing that I'm going to do is I'm going to CD into the Deep Blue CLI master directory, like so. Let me close this out. And let's open up that terminal again. All right, CD. I keep making that same mistake. You would think after teaching this class dozens of times, or a dozen times, that I would not make said mistakes anymore, but it brings joy to my life when I make mistakes. Why would I like mistakes? I don't know. Let's do a little riff on that. Why would I be pretty cool with mistakes, all told? Anyone know? No, Cyber Mentor does not work for SANS. Never, never. And I never wanted to insinuate that. I'm saying Cyber Mentor, the TCM Academy is awesome. They have great instructors is what I meant. You learn from mistakes, right? You learn from mistakes, right? And honestly, a lot of the stuff that you see in this class that I do really well, where I'm not even really thinking and I'm typing while I'm doing stuff, is actually stuff that I failed at multiple times. So those failures are awesome. And there's a great quote, moving from failure to failure without loss of momentum and exuberance. I think I got that wrong. I butchered it, but it's a great quote, right? It's a great quote. Also, I love mistakes for this reason. When I was teaching and kind of working and doing things, if I ever was teaching with somebody and they were a student and I typed ls in a Windows command line or dir in a Linux command line, or I forgot a / on an FI, and you had somebody that's like, actually, I can't believe you made that mistake and you're a SANS instructor, I immediately knew that they were a-holes and I didn't want to party with those people. And I love it whenever people make that, like a parent, because now I don't have to waste any time. That's really good. So one, don't be afraid of mistakes. They're awesome. They're really, really cool and they're learning experiences. So embrace them, embrace the suck. And number two, don't party with people that like to point out the faults of others. Don't party with them. Don't party with them and don't mate with them. No more a-hole babies. We got to be careful about those things. All right. So let's go ahead and let's keep rolling. What? All right. So now we're going to set the execution policy to unrestricted so we can do whatever we want from the PowerShell command line. By the way, all these little side channels and all these different things and all this different stuff. I'm sure that there's people like, oh my God, he's going down a rabbit hole and he does this all the time because he's caffeinated, because he was tired and he decided to have a cup of coffee. But you shouldn't judge me, because if you are judging me, especially those of you that like jump out at this particular point, you're going to miss this nugget. I just went into PowerShell. PowerShell's logging, right? Right? And we're running Deep Blue CLI on the PowerShell logs. Did you know that if you install PowerShell from the Windows Store, like post-exploitation, using the Windows Store to install PowerShell, the version of PowerShell that it installs from the Windows Store is unhooked from AMSI? What is AMSI, folks? What is AMSI? Come on. The people are like, what does that mean? What is AMSI? What is AMSI? Microsoft AMSI. It's the anti-malware scripting interface. What does that mean, boys and girls, if it's unhooked from AMSI, the anti-malware scripting interface? Nope, it works like a champ. It's validated by Microsoft. It comes straight from the Microsoft store. Smokey did it. Freedom. It doesn't just get not logged. It's completely blind to antivirus on the system. So what that means is you hit the system, you load PowerShell from the Windows Store, and the version that comes from the Windows Store and runs means that you can run your malware all day long, ladies and gentlemen. Why would Microsoft do that? Because they like me, because they like pen testers, because they like hackers. Yes, it does in fact seem like a security flaw, doesn't it? And it's been that way for a long time. So these crazy screeds that I have whenever I'm heavily caffeinated, sometimes there's nuggets of awesome things out there. All right, so let's keep rolling. All right, so we've got this. The first thing that we're going to do is we're going to do a quick check for new users that are added onto the computer system. So let me paste this in. By the way, that worked up until last week. That's actually worked for a couple of years on there. Yes. So if you download PowerShell from the Microsoft Store, you can run things without antivirus detecting what you're running. Yeah, there we go. All right, so I'm going to go ahead and run this script like so. There we go. And there we go. And we can see that we have a number of users that are created. We have the IE user, and then we have, what the hell? Do you guys see anything weird there? You guys see anything weird there? We have an administrator user with the name of Dash as an admin. Yeah, that would be bad, Ray. So that allows us very quickly kind of going through and giving us a list of all of the users that were added. So that's fun. What's another one we have? Ooh, password guessing. We're looking at the event logs and we want to see if anyone's doing a password guess. What is the difference between a password guess and a password spray? Go, the internet. Password guess versus a password spray. What is the difference between these two things? Guess equals guess on many accounts. Joseph is there. And a password spray is one password on multiple accounts. Excellent. Very, very, very good. So password guessing is where I'm trying a single password on multiple passwords on a single account. What will happen if I do that long enough on the outside of an organization or internal? Like if I try to log in, I'm going to get locked out. I'm going to get locked out, right? I'm going to get locked out. But a password spray is different. What a password spray does is it allows us to go through and try a single password against multiple user accounts. Therefore, we bypass the lockout because we try one password against multiple accounts. And in this situation, you can see this password guess. We have 3,560 failed login attempts for the administrator account on the system. Now, why would the attackers be focusing on the administrator account? Ladies and gentlemen, boys of all ages, why would we focus on administrator? It's higher privileges. Excellent. God mode. Also, by default, can you lock the local administrator account out? No, you can't. So it's a great account to do a password guess against. Now, the other thing is, can I access the local administrator account over SMB? Can I remotely log in with like net use star / IP address /C dollar? I can put in the user of administrator and try the passwords. No, you cannot. Since about 2008-ish, you have not been able to log in remotely onto the administrator account. The only way you can log into the administrator account is these two ways. Way number one, at the keyboard. Way number two, over remote desktop. So if you're looking at a modern system and you see multiple failed login attempts for administrator, odds are it's somebody is using like a bash bunny or they're doing RDP and trying to access it as well. But we should all implement laps, HK points out, and I agree with that. So very, very, very good point. And also things like AnyDesk and TeamViewer would fall into that account as well. Nope, can't use it with WinRM. Nope, 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 nope. All right. Do you guys want another piece of odd trivia with Windows computer systems that you should never, ever use? Ever. Anybody? I mean, if you don't, that's cool. I understand that. I get that for sure. Okay, you do want to know it. You cannot log in remotely on an account on a Windows computer system if the password is blank. If it's blank password, you can't log in. Now you can on RDP, but over SMB, you can't. It will not allow you to log in. It just won't. So that does not mean, no, God damn it, Brian. That is not what I meant. I did not say we should never use, no, you still want to use passwords, okay? You still want to have passwords. Do not take that to mean that you should set all your passwords to blank. That's not what I meant there. No, bad. That's not what I meant. All right. So let's take a look at a password spray. Because why not? Password sprays are awesome. So this is an attempt with one user account to try to authenticate to multiple other user accounts with one password. So here you can see that this account, Jay Wright, tried to authenticate to all of these target usernames. This is the sign of a password spray on that system. So that's pretty fun. Oh, this one. This is the part where you're like, now we get to see the limitation of John Strand's knowledge of computer hacking and hackery. Let me show you where that is. Okay. Now, I could spend some time going through and learning all these different types of obfuscation, but who's got time for that? So it's like trying to learn Perl, I guess, or looking at AI generated Perl. All right, so here we go. So Deep Blue CLI has the ability to look at how a program was invoked, and based on how that program was invoked, it can identify potential obfuscation techniques. So once again, this is important for a SOC analyst because a SOC analyst is, a SOC analyst is going to look at this system, they're going to see what executes, and they're going to try to detect whether or not there's some type of malicious, weird execution. And these types of obfuscation techniques pretty much are a smoking gun that there's really bad things happening on your computer system. Why? Because normal developers don't do this most of the time, not always. So let's go through these as well. So number one, let's start with this one. This one says suspicious command line, possible obfuscation. Only 60% of the characters are alphanumeric and common symbols. If you look at how this is going through and executing, you can see that there's these crazy upper and lowercase camel characters. There's spaces added in. That's weird. Like that's not fun, right? That's just not good. All right. That's bad. That's really, really, really bad. Okay. So that's number one. I know what that one is. Okay. I get that. Like, I'm not that new to computer security that I can't look at that and be like, yeah, that's some type of obfuscation. The next one, also equally comfortable with. With this one, it says it's a long command line greater than 1,000 bytes, possible command obfuscation, only 6% alphanumeric and common symbols. Interesting. What are they doing? They're putting in a bunch of white space at the beginning of their command. Look, here's the command. That is white space. Bunch of spaces. Space, space, space. Could be tabs. Could be spaces. Can't be tabs and spaces. Tabs and spaces don't get along in the world of computer programming. They don't. Tabs, not spaces, right? But if we scroll down far enough, we finally see the command down below, which is the same command as up above. What the hell is the attacker doing? What the attacker is doing is they're creating a bunch of white space in front of their command to get outside of the buffer for detection. A lot of detection buffers, well, it used to be this way more than it is today, but there's a lot of detection buffers for detecting an attack that will only set the buffer size to a certain length. If something goes over that buffer, it ignores everything. So what we're trying to do here as an attacker is create a whole bunch of space at the beginning to flush our attack at the end of what the buffer would be on this. That's way different from a no-op sled. A no-op sled is completely different. I don't think I have time to get into it dancing, but I'm going to go through it as quickly as I possibly can. So whenever you're doing a buffer overflow attack, all right, you set a return pointer. So whenever your code executes, it doesn't actually execute the code. What you're doing is you're overwriting the instruction pointer with a return pointer. In your computer system, there's something called address space layout randomization. That means memory contents and locations will shift. You can't jump directly to a specific area in memory because it's shifting all the time. However, if you have a large enough buffer, you can put in a series of no-ops like 909090909090909090909090909090909090909090. And what happens is whenever you hit your return pointer, if it lands anywhere within that realm of that no-op sled, it slides down to your Easter egg, which is your shell code, and then it executes. The reason why this is important is instead of trying to land into a specific area of execution in memory, it creates a funnel that's much, much, much larger in the form of a no-op sled, where if it lands anywhere in that no-op sled, it still slides down and executes your shell code. So there you go. That is a no-op sled very, very quickly. Does that make sense? If so, awesome. If not, probably should talk about it at some other time. But let's keep moving. Yo, you think your brain hurts now? Wait, because it's about to get weird. All right. So let's do this. Let's go to terminal. Let's go make this bigger. We go man ASCII, and we get this wonderful table. That's the ASCII table set. And we have octal, we have hexadecimal characters, we have decimal sets, and these are representations of characters, and your computer understands them equally. So whenever you see a capital A, when you see a capital A, you see a capital A. When your computer sees it in hexadecimal, it sees a hexadecimal 4-1. Capital B is 4-2, and so on. Okay? So your computer honestly reads a whole bunch of different types of encoding that it'll process just fine, because we see ASCII, it can read hex, it can read decimal characters, it can also read octal characters as well, it can read hexadecimal. I'm not kidding you. There are all kinds of different things that you can encode your malware in a variety of different ways, and it will still execute. Okay? So this gets mind-bendingly difficult, but also kind of awesome at the exact same time. So what we're seeing here at this point is we're seeing the characters being invoked and their different hexadecimal values. So you can see character 73, character 69, character 88, character 32, character 40. So instead of seeing the ASCII characters, you're seeing the hexadecimal representations of the characters. Wait, before you get too excited, it's about to get worse, right? So this is a type of encoding. Would a human being do this? Why? What the literal hell, right? Like, this is freaking crazy pills, right? It's now they're hiding what's going on. But Pokey, look at this, right? It's a little hokey. It's weird enough that a tool like Deep Blue CLI can see these types of obfuscation and say, that's not normal. Humans don't do that because that's crazy pills, right? So now we're kind of setting up some level of detection. Then we get to this. I don't know. So you remember what I was telling you about how your computer can read a variety of different types of like encoding and obfuscation? Now we kind of hit the limit, and I know that there's people out there that be like, I know what that is, and John's a moron. I don't know. This is generated by a tool called invoke obfuscation. And if you're afraid of math, this is the stuff of nightmares, right? This is absolutely insane. But here's the deal. It'll execute, right? But wait, there's more, right? If we go down, we're doing that same character substitution, but instead of invoking each character, we're loading them all into an array, right? This next one, I do know this is base 64 encoding, just straight up base 64, which is another type of encoding. It's there. And then, of course, we also have freaking binary. That's crazy. So these are all the different types of encoding that you as a SOC analyst should be on the lookout for. Because if you see this stuff executing from the command prompt or from PowerShell, as a SOC analyst, you should say, okay, that's not what a normal human being does. Something very wrong is happening at this point. We need to investigate it. It doesn't really view it differently. It honestly, I guess the best way to put it is it honestly doesn't care. So here, let me show you something. Okay. So there's this one coding language right here. Let me show you. This is the most complicated coding language in the world. This is the program for Hello World right there. Like here, let me share this with you all so you can see this, right? There you go. You guys can all play with this. Here's a cat program. This program reads in a string from a user and prints that string, similar to the Unix style command line utility cat. Right? Like this is nuts. Like look at this. Here's the value of C plus C percentage 94 for jump D to a value. What the who, who does this, right? Even the guy that wrote this language can't write programs in this language. Like this is the most complicated language in the world, right? And then you have let's go ahead and let's do so if we do a search for complicated Perl examples. Oh, not compliance. Right? Like really, really crazy. Like, look at this. This is Perl, right? We can write our code utilizing this type of stuff. And there's a ton of ways to write this code. You can do assembly with only subtracts. So you can do you can do entire assembly programs with just subtraction with no addition, where you can do minus minus instead of a plus. So there's a ton of these different things that exist out there that are just absolutely insane, but they're all awesome. And one of the things that you'll notice very quickly as a SOC analyst, if somebody is trying to do this type of like this type of weird shenanigans and this type of encoding, you can look at it and be like, that's weird. It needs to be investigated on that as well. All right, so there we go. All right, so let's talk a little bit about server analysis. Then we're going to take a 10-minute break. Hopefully you're all getting ready with your Ask Me Anything questions because we're going to close out with another Ask Me Anything. And when we're looking at servers, right? Okay, we're disconnecting, right? We're done with Windows command line, y'all. We're done. We're going to take a second and we're going to look at log analysis and servers and what do we find and how do we parse and what are the tools that we do to parse logs. I'm going to warn you, this next section is going to suck. All right. This next lab is just like, crazy pills. But just stick with me. All right. It's important. All right. So the first thing is anytime you're looking at a server, you need to be looking at the server through the perspective of where the logs are. How do we parse the logs on that server? So you can see right here, we have the access log on web logs for this system, and we can see who's accessing it. And look at this. Look at this. We've got a bunch of weird encoding, right? We got %2f, 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 which is // Windows / system.ini. All right. That's an attack. Prevent 5C, 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 // and then Windows system.ini. We're seeing these attack patterns in this access log, right? Error log. You can look at a weblog error log. So you can see all the errors for an Apache server that comes up and they tell you these are the different attacks that are not attacks, errors. It's like, I have no flipping clue what the request is that came against me. So I'm just going to throw in this log and you all can look at it later. Next one is authentication style logs, right? So when we're looking at an authentication log, we have somebody's trying to authenticate as root, failure, 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 and then finally they successfully log in as root. This is an attempted password spray via SSH, right? So we're seeing these things. Now, Mildoc Jr. brought up grep is your friend, right? And turns out it's a little more complicated than that. In fact, we're going to have a lab that we're going to jump into before we talk. This is going to be the last lab of the day. And when we start up tomorrow, we're going to talk about how we deal with this stuff, but we're going to talk about log parsing. All right. And this lab is one of my favorite labs because people ask me, like, what are some of the most commonly used tools? We're going to do a firewall log review lab. So let's say that you're a SOC analyst. All right. And you're tasked with doing analysis against the logs from something horrible, something truly awful, something deep down evil that no human being should ever have to parse. Let's say Cisco ASA logs, just throwing that one out there. Adaptive security appliance logs. This lab is going to show you how I parse an attack against an ASA log. But the tools that I use going through this lab are the exact same tools that I use all of the time. And I'm going to start tomorrow by doing a walkthrough of this lab. So you're going to open up a Linux command prompt on your system. We're going to start there and we're going to CD into oh, I want to get out of that. Let me close that, close that, close that, close that. I'm going to get you all started with this lab because I'm going to do the walkthrough in the morning when we come back. So let's go ahead, open up an Ubuntu command prompt, and now we're going to type the clipboard text. We're going to move into intro labs, and then we're going to update the system. Ubuntu, ADHD is the password. And we're going to install a tool set called RBase Core. RBase Core is a series of math-like functionality that you can embed inside of your bash command prompt so that your Linux system can do mathematical functions dealing with statistics. And we're going to deal with that here in a little bit. So it's uploading and updating, which is great. Here we go. It's coming. So you're going to install RBase Core. And then we're going to do the lab. So I'm going to walk through what your goal is. Somebody said grep is important, and they're 100% correct. So you're going to grep out a string that is an IP address. So this is a suspect IP address. All right. So what happens is a lot of times as a SOC analyst, you start doing an investigation based on one bit of information. This IP address appears to be compromised. You start doing analysis on that IP address. So we're giving you like, this is an IP address that is compromised. Then we're going to show you how we can use grep to grep out every line that does not have this IP address. This is the local gateway. Next, we're going to show you how we can take grep, look for specific flag like fin. So we're doubling up our greps. So we're grepping this IP address. We're grepping out that IP address for our gateway. And then we're grepping out all the lines that have fin. So we're creating these filters saying, I just want this IP address, but I don't want any lines with that IP address. And now I want to see only the lines with fin. Then I can specify delimiters and I can specify which fields I want to investigate. These tools, grep and grep, the inverse, and using cut are the tools that every security analyst on the planet needs to know. You're only updating the Linux system. And we're going to continue to work through that and make this more complicated as far as the grep statements. But at the end, we're going to be using the RTools package that will allow us, let me show you what it looks like when it's done. But the RTools will allow us to do math. And I'll show you what kind of the last step of it is. Let's go here. So we're building it up. And then we're going to have this command do, oops, I forgot to install my R-based tools. Let me copy that one. That's the one I wanted. So we're going to install the capability to do math. Takes a couple of moments. And then what we're going to do at the final phase is we're going to do math on connection intervals to identify beaconing in the logs. So this lab, like what we're doing with grep, what we're doing with like using cut, identifying delimiters is something every one of you needs to know. And we're just using it against the ASA logs as an example. So you're going to get these logs. They're going to be a mess. There's going to be a bunch of text. You're going to be like, crap, how do I go through this to pull out the stuff that's interesting to me? And this lab will show you how to do this. I'm not kidding you. When you go and apply for a job, if you're comfortable with explaining how you use grep, how you can use translate, how you can use like cut to be able to go through event logs to parse and figure out what's going on, the world is your oyster. All right. So that is the lab. We're going to take this up to and through the break and then on the other side. So we're going to start the Ask Me Anything to, we're going to start the Ask Me Anything at quarter till. So we're going to start, 45 after 15 till. We'll do that. And then tomorrow I will do the walkthrough of this lab for everybody step by step. And we'll talk about what it's really, really important. I'd probably say grep is more closely related to regular. Oh, you're talking about PowerShell at that point. Sorry, that's something different there. All right, everybody. So with that, let's go ahead and let's get rolling on the lab. And if you need anything, please let me know. And we are back and ready for an Ask Me Anything. So let's do it. What questions do you all have? Like I said, tomorrow I'll do the walkthrough of the, I will do a full walkthrough of this particular lab, which is an awesome lab. And once again, it's not like you're going to be parsing ASA logs all the time, but really what you're going to be doing is using these same tools like grep, awk, cut, RTools to be able to do analysis on those event logs, regardless of what the log is, as well as that. What's the most surprising incident you have ever witnessed? We were just the first one that pops into my mind that doesn't involve children is I had an incident where we were pen testing and we gained access to an administrator's workstation. And we noticed that the administrator had an RDP session to his home computer, and from his home computer, who is hacking a bunch of web servers in Canada. And we took a screenshot of that, shared it with the customer, and then sent it to law enforcement. And law enforcement basically then started the full investigation of what this person was doing. And we spent about 2 to 3 weeks capturing all the keystrokes and full video recording of what this person was doing to basically capture him. So that was a surprise because it was during a penetration test that it actually jumped out at us. If you had any superpower, what would it be? Would it involve loss of your sanity? So right now, my superpower, I have 2 superpowers. One, I fail again and again and again. And I don't really care if I fail. At this point, I'm far less self-conscious than I used to be. My other superpower is sleep. I have the ability to sleep. I can go to sleep. Like right now, I could lay down on the floor and sleep. I'm very, very good at going to sleep. And I think that that's a great superpower to have. But if I could add one more, it would be the ability to eat anything I want without gaining a lot of weight. I think that that would be pretty cool if I could do that one. Any recommendations for dealing with imposter syndrome? Just get out there and get embarrassed. again and again and again, fail in front of people again and again and again, just work through those things again and again and again. Because seriously, the more like you're exposed to failure, the more you're exposed to that risk, and the more that you realize, honestly, that the people that judge you from like you making little mistakes are assholes, and people know that they're assholes, and then we all kind of marginalize the assholes, the better off it is going to be. There's a couple of different quotes that kind of lead into this. Don't swim across oceans for people who won't jump across a puddle for you, right? And a lot of the people that are very judgy are the people that won't jump across a puddle for you. Or another way to put it is we get so caught up in trying to get affirmation from assholes because we think that their affirmation is worth more because it's hard to get. And that is absolutely untrue. Stop trying to impress other wizards. Stop trying to impress assholes. You will never succeed. They're hurt, like really wounded people. And the only way that they feel whole is by attacking other people. And I will tell you, in the industry, there's going to be people that call you out. There's people that are going to call you poo-poo head. And granted, it hurts. It really does. But you'll realize that they're a minority, and you just keep moving on and try to ignore them as much as you can. There
Hey,
you go.
John, I have
Yeah.
a question here from Zoom.
Yeah.
So, what are 3 pain points of IAM and how would you solve them?
Identity and access management, the three biggest pain points that we see are really easy pain points to implement. The first pain point is implement two-factor authentication. Whatever identity and access management solution that you work with, there should be a component of identity and access management. And when you're looking at like Google Authenticator and Microsoft Authenticator as like the main 2 points that everyone can tie their authentication tools to, and there's great toolkits that are freely available, you should be able to turn that on for just about any service that you have. The second one, even if you do enable two-factor authentication, you still have to make sure that you have strong passwords. It means passwords of greater than like 14 characters, upper lowercase, alphanumeric, special character, allow people to use dictionary words, encourage pass phrases. But if you're tying your authentication to Google or you're tying your authentication for identity and access management to Microsoft, you're going to do really well. Just make sure that you have two-factor authentication, you have strong passwords. But the third thing that's the hardest is those two things, strong passwords and two-factor authentication, need to be enabled freaking everywhere. It isn't good just to have it in one portal and then some API for a mobile app completely bypasses it. The attackers are going to find those things. So 3 things: multi-factor authentication, continue to enforce strong passwords, and the final thing is make sure that you enable those identity and access management like kind of axioms everywhere. Good question. What's the favorite malware that I've ever seen on a client's network? I always like it whenever I see malware on a client's network that's like malware that BHIS has like created or proof of concepts that we've created. And the reason why I like that is if I ever talk to attorneys and they're like, what makes you an expert in this malware? And it's like, yeah, it's basically malware that we wrote and shared as proof of concept with defensive approaches. So that's kind of fun. Will you come to Canada to do an on-site pen test? Me? Nope. No, 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 no. I've done it. I've gone to Halifax, Nova Scotia, and had a great penetration test there. A lot of fun. But no, I'm done traveling for a pen test. I don't even like traveling that much for cons anymore. I'm getting ready to do a world tour in Europe, or a European tour. I'm going to be in B-Sides Krakow. I'm going to be at B-Sides Frankfurt. And then I'm going to be at BrewCon. So I'm going to be teaching and presenting at all 3 of those different conferences. So I'm pretty excited about that, but I don't really travel much anymore on that. Why do we need to invoke a new instance of PowerShell in Deep Blue CLI directory? Is it because it automatically sets some environmental variables to use Deep Blue CLI? Nope. It's just I had you go to that directory to run it. We could have done it a number of ways. As long as you're running PowerShell and you invoke and import the functionality from the Deep Blue CLI PS1 file, it's going to work just fine for you. Hey, I just found out it looks awesome. Quickly and catching up by the next stream. You should be able to. All of our stuff is in Discord for the recorded videos, and I think it's also stored out on YouTube. So you can see our previous sessions out there. Parsing and normalization. What a great question, Mitsu. This is computer science. So parsing is basically what we're doing in this lab, where we're parsing out and we're pulling out the different data sets that are interesting to us. Normalization is basically a database term that involves normalizing the data across multiple different points. An example would be, let's say we have a field in one file that's called IP. Right. And then we have another field that's called IP ADDR. And then we have another field that's called IP underscore ADR or IP.A, right? Data normalization would be taking multiple different disparate data sets and then making sure that they conform to the proper data sets to merge them into a unified database. There's a lot of tools that do this. One of my favorites is Logstash. If you use Logstash for data ingest in an ELK stack, Elastic, Logstash, and Kibana, Logstash allows you to normalize the data sets so that they can be indexed and searched properly in Elastic, even though the way Elastic works as a NoSQL database is different than a relational database. But that normalization is basically where you take the data, parse it to a format that can be easily indexed, and then store it. This can be represented in multiple different ways. We can basically normalize header field values. We can normalize data values themselves. And then ultimately what we can do when we're dealing with data normalization is do things like materialized views and stored views that take multiple data sets from multiple tables, move it into smaller subset tables that have the actual data of interest to us. And then we would do things like indexing on those tables to speed up the process of searching across that data. So great question. Very cool. How do you recommend practicing IR? Yeah, what you're doing here is all about that, right? Infecting the machines, reinfecting the machines. I would recommend going through and looking at attack tactics webcasts that we've done and kind of walking through that. And there's going to be a lot more of that stuff. Basically, I would recommend Pokey. Just stay tuned with anti-siphon and BHIS webcasts because we got so many things that we've been holding back for a while now. And really, even with me holding back a lot of the shit that we have coming down the pipe from anti-siphon and BHIS and Wild West Hacking Fest, we still have been doing 2 webcasts a week. It's been a huge clip. So subscribe to BHIS and the anti-siphon webcasts and Wild West Hacking Fest, because I'm telling you, in the next 45 days, we're rolling out a new lab for this class. We're rolling out a certification for this course. We're rolling out some more stuff for corporate and organizational training. That's paid training. And then I have a workshop for wireless hacking. Like, there's so much coming down the pipe. Stay tuned and subscribe to what we have going on out there as one. Capital One testimony, that is where I testified against Erratic on behalf of the state, who hacked Capital One through Amazon and basically going through proxies to gain access and make request calls to query data directly from Capital One out there. What made you start these inexpensive trainings? It was purely by a mistake. I'm going to explain more on day 4, so stay tuned. And day 4, by the way, to keep you all coming, we're going to be giving out a discount code for free t-shirts. Not this one. I've got other shirts. But we'll be giving out discount codes to get free t-shirts. You'll have to cover shipping, but the t-shirt will be free. So be sure to come on day 4 and I'll tell that story as well. Is enabling Sysmon viable anymore due to the rise of EDR, providing events to a set tool like LogScale? Keep in mind costs or not. So one of the things that I want you to look at, Jason, is I want you to look at it from the perspective of look at the current event logs that you get from Windows, the application security and system logs. They're garbage. They're absolute garbage, the vast majority of them. And then Sysmon all of a sudden gives you these magical logs that gives you everything you would ever want as a second backup to your EDR. Don't look at Sysmon as like, oh God, it's even more logging. Look at it as logging the right thing. And in the security class that is the next one from this course, we actually go through and we talk about how to test your EDRs and test your logging facilities to make sure that they're working properly. What's my take on incident reports? They're broken. We're going to fix that in Q1 of next year. Stay tuned. Favorite programming language is probably PowerPoint this phase because I'm a manager. But all joking aside, Python is the best one to look at. How much do I sleep daily? Anywhere between 8 to 10 hours. There we go. Sleep, AK, depression. Nah, that's Yeah, so I was fairly depressed and I was starting to get suicidal and I gave up alcohol and that solved that problem for me. I'm not saying that works for everybody, but hey, it's something worth trying. How did the anti-siphon name come about? We asked this yesterday. Anti-siphon is two separate things. Like I like the idea; it looks neat, right, as a word. Also, an anti-siphon valve keeps like fluids where they should be. An anti-siphon is all about keeping data where it should be, so it can't be siphoned and stolen. Well, that's anti-siphon. Also, we're computer security training that doesn't suck. CISP is a money grab, not worth it. I somewhat disagree. I think it's great that we have a certification that's $400 and it's attainable by a lot of people and it's affordable and it creates a common taxonomy as far as language and terminology. I disagree with some of the things in it, but the concept is pretty solid out there as well. How to handle politics in cybersecurity, ignore all of it and just do your own thing and be awesome. You're going to have people that call you into fights and they may be justified fights, right? Like, oh, this person, Jonathan, everyone's mad at him because of some shit he said at DEF CON. I don't care. I don't know Jonathan, right? Like, I'm not going to get on and start making fun of him. Now I disagree with him, right? I completely disagree with him. I think what he says is abhorrent, but I'm not going to get in and start arguing with this Jonathan dude on Twitter because he said something that was technically incorrect and he's an a-hole. Just avoid the fights that don't move the world and your own personal life forward. There are times where you have to throw down, and I have thrown down. There's been limits. I had a con that basically pulled the rug out from underneath me about somebody that was presenting at that con, and I had to put my foot down in a public way. Normally, I would have handled that shit in back rooms. I wouldn't have brought blood into the streets, but I had to in that situation as well. Enterprise on a find long. What skills, what do you be skills over certification? I really like cyber ranges because it really analyzes and pulls down both that we have out there as well. And if they're a-holes, do you really want to be part of their group anyway? I agree with that. Oh my God, I am so far behind on questions. I
Yeah,
feel like
I don't think that you're going to be able to get to them, sir.
I
It is
don't
4
think I'm
o'clock.
going to be able to. All right. So, folks, one of the things, geez, how many questions did,
There's
oh,
too many. There's
there's
way
too
too
many.
many.
There's too many. Also, a lot of people have asked questions about mentoring. Megan, we get a lot of that.
Yes.
I don't do individual mentee mentor relationships.
Yes.
And I want to explain why. This class is why. We had 1,700 people registered, and we're averaging anywhere between 400 and 500 people live every single day. I can't do mentor mentee relationships in that situation. I just can't. I'm also a horrible mentor, right? I ask Megan and anybody here that works for me. I'm off doing 1,000 different things, and it's honestly Megan talks to me more than almost any other like employee at Black Hills Information Security. Honestly, truly. We have a lot that's going on. So with me, this is my way of doing the mentor-mentee relationships, these pay-what-you-can trainings that are publicly available, so I can try to help as many people as we possibly can. All right. So like I said, keep showing up, and I will see you tomorrow. We're wrapping up. Let's kill it with fire. Thank you so much, and I'll see you same time, same channel tomorrow.
All right. Have a good evening, everyone.
Later, everyone. Bye bye.
Yuri, kill it with fire.